Hello everyone, welcome to today's video where we will be exploring the linear search algorithm. We will start by understanding what linear search algorithm is. Next, we will dive into the mechanism of how linear search algorithm works. We will then explore the pseudocode to get a clear understanding of the logic behind the algorithm. After that, we will transition to the implementation phase where we will be implementing it using Python. Finally, we'll touch on the big O notation, providing insights into the efficiency and performance considerations of linear search algorithm. By the end of this video, you will not only know how to implement linear search algorithm, but also understand when and where it is most effective, because we will also be discussing where linear search algorithm is most effective. And with that, let us just dive right in. And I want us to start by understanding what linear search algorithm is. Now, linear search algorithm, also known as sequential search, is a simple searching algorithm that is used to find the position of a specific value, or rather a target, within a list. It sequentially checks each element of the list until a match is found or the entire list has been traversed. Let us understand what that means using an example. Suppose we have this list of elements 45, 12, 90, 64, 53, 22, all the way to 5. How do we find a value like 23, or how do we prove that 23 exists in the list? The simplest way is to go through each element and confirm if it is the value that we want. And essentially that is what linear search, or rather sequential search algorithm is. And in this example, we'll start with this 45 and compare it with 23. Is it what you're looking for? No. We'll then move to this 12. Is this 12 23, or rather, is it what you're looking for? No. We'll then go to 90. Is it what you're looking for? No. Is this 64 what you're looking for? No. Is this 53 what you're looking for? No. Is this 23 what you're looking for? No. Is this 12 what you're looking for? No. And is this 23 what you're looking for? Yes. So once we find that particular element, then we take an appropriate action depending on the needs of our program. Maybe just return a boolean to indicate that indeed that particular value exists or doesn't exist, or maybe if we found it, we can just do a slight modification or even delete it. Now let us look at the pseudocode to understand it clearly. Now, the first thing to do, just create a function that accepts an array, or rather a list and a target, and then loop through the list, and in each iteration, check whether the current element in the iteration or in the list is equal to the value that you're looking for. And if it is, return the index at which the current element was found, or return a boolean or any true value. Just take an appropriate action depending on what your program is trying to do. And if you reach the end of the array or the list and you haven't found the value that you're looking for, return false. And that is what we are having here at the end of our pseudocode over here. Just take an appropriate action depending on what your program is trying to do once again. Now let me jump into my code editor and show you how that is implemented using Python. Now I'm just going to create my function here, and I'm just going to call it linear search. Now this function is going to take in the target as the first parameter, and it's going to take in the list where we're trying to find this target as the second parameter. Now I want to go through each element, and I'm going to use the for loop. I want to go through each element in the list, and in each iteration I want to check if the element that you're currently looking at is equal to the target. And if that is the case, for me, I'm going to return true to indicate that indeed that particular value exists in the list. Now, if I reach the end of my list and I haven't found that particular element, I'm just going to return false. So you can imagine if we found our element in the middle of the list, then we'll just do an early return, and we will not be executing this return false over here. But if we reach the end of the list and we haven't found that particular element, we'll come all the way to line 7 and return false. Now let me call this function linear search, and I want to search for a value 23 in a list, let's say something like 45, 34, 90, 67, and then maybe 23 and 55. And since this function is expected to return something, I'm just going to wrap all of this within a print statement so that we see that particular value that is being returned. Let me open my terminal, and then I'm going to run my my file from the terminal. So Python linear search.py and hit enter. And you can see I'm getting a true because 23 actually exists in this list over here. Let us do the same for something that does not exist and see if you're going to get a false. Assuming I want to search for a value like 235 in this list, we know it doesn't exist here, so we are expecting to see a false. Now, once again, if I run that file, you'll see I'm getting a false, and that essentially means that our program is working as expected. Now, let us look at the big O notation of linear search algorithm, and essentially, in the best case scenario, linear search algorithms runs in O of 1. You can imagine if the element you're trying to look for is located at the beginning of the array. So I'll just go back to the code, and you can imagine if you're looking for this 23 and this 23 is somewhere here, then this would run in O of 1 because that is the best case scenario for linear search algorithm. And then for the average and the worst case scenario, linear search algorithm runs in O of n because it will make approximately n comparisons to find this 23 in this list over here. And for this 235, it will also make n comparisons to try to find whether it exists in this particular list or not. Now, let us end this by understanding where the linear search algorithm excels the most. And the first place where linear search algorithm excels the most, or rather is most efficient, is when you are doing the first occurrence search. You can imagine if you have a list of elements and you want to find the first occurrence of an element, then linear search algorithm would excel here because it will stop as soon as it finds the first match. So going back to the code editor, you can imagine if you are trying to find the first occurrence of 23 in this list over here, then you know that once our algorithm sees that this 23 is actually there, then it's just going to do an early return because it's going to stop as soon as it finds that particular value. Now, there are other searching algorithms out there, such as binary search and interpolation search. But when it comes to finding the first element, or rather the first occurrence search, none of them works better than linear search. The second scenario where you would want to use linear search algorithm is in sequential data access. So linear search is effective when data to be accessed is sequential, and there is no easy way to jump to a specific location. You can imagine if you're using something like a linked list, and if you don't know what a linked list is, don't worry. You can just do a quick search on the internet and you'll actually understand what it is. But you can imagine if you have a linked list and you want to access an element in the middle of that particular list, there is no easy way to just jump into the middle of that particular list. You have to move through all the elements sequentially until you find what you want. And then last but not least is in searching unsorted arrays. So when dealing with arrays that are not sorted, linear search is often the method of choice here because it will sequentially check each element until a match is found. When we have sorted arrays, we have the binary search algorithm, which works better, in sorted arrays. But in unsorted arrays, linear search algorithm is one of the best algorithms to actually consider. So that's it about linear search algorithms. Thank you for sticking around, and see you in the next one.